3 times. That's all it takes. 3 interstellar objects passing through our cosmic backyard, and suddenly, the question isn't whether the universe is visiting us, it's what exactly is arriving. On July 1st, 2025, a telescope in the mountains of Chile picked up something unusual. Not a typical comet following the familiar dance of our solar system. Not an asteroid bound by the gravity we understand. This object was different. This object was moving at 137,000 miles per hour. This object, astronomers would announce, had come from somewhere else. It had a name, 3I Atlas. The 3 stood for a designation, the third known interstellar visitor. The I stood for what we all wanted to know, interstellar, from another star, from another world, from another system entirely, drifting through the cosmic void for millions, perhaps billions of years, until it arrived here, until it arrived now. And this is where the mystery deepens. This is where the science becomes strange. But before we begin, if you'd like to support the channel, please take a moment to like and subscribe. I can't thank you enough for your support. And also, I'd love to know where you're tuning from and what time it is there. It makes me so happy to see how these videos connect people from around the world. Now, settle in and let's dive in. Let's establish what we know, the facts, the observations, the data that astronomers around the world can verify and measure. On July 1st, 2025, ground-based telescopes in Chile detected an object approaching our solar system. Within days, archived footage revealed that these same telescopes had captured pre-discovery images dating back to June 14th. The object had been in our cosmic neighborhood longer than anyone realized. Quietly, unnoticed, moving steadily toward the sun. The detection happened through a systematic network. The ATLAS system, Asteroid Terrestrial Impact Last Alert System, NASA-funded, watching the skies, was designed to spot dangerous near-Earth objects, rocks, asteroids, potential threats. But on that July morning, the instruments found something the system wasn't built for, an object that didn't belong to our solar system at all. Within hours, the data was cross-referenced with archival observations from other ATLAS stations around the world and from Caltech's Zwicky Transient Facility at Palomar Observatory. The evidence accumulated. The conclusion became undeniable. This comet had originated from interstellar space. The scientific community mobilized. Telescopes across the globe turned their attention to this wandering guest. NASA's Hubble Space Telescope captured detailed images just 3 weeks after discovery. The James Webb Space Telescope, humanity's most powerful space-based observatory, directed its infrared instruments toward the object. Teams of astronomers, some who had studied the first interstellar visitor, Oumuamua, discovered in 2017, recognized the signs immediately. The hyperbolic trajectory, the velocity that no closed orbit could explain, the trajectory that, when traced backward through time, led away from our sun, away from Earth, away from every star system we call home. This was not a local object. This was not something born in the solar system where dinosaurs once walked and humans now live. This was something from the galactic frontier. This was 3I Atlas. Now, here's where it gets interesting. The mathematics are precise. The orbital mechanics are unambiguous. When astronomers calculated the trajectory of 3I Atlas, the path it had followed to reach us, they discovered something remarkable. The comet was approaching from the general direction of Sagittarius. In that direction lies the galactic center of the Milky Way, the densest region of our galaxy, where billions of stars crowd together in the cosmic dark for millions of years, perhaps billions of years. 3I Atlas had drifted through the void between stars, through the infinite black, through regions of space where no sun warms anything, where no light reaches, where temperatures hover near absolute zero, and somehow, impossibly, it survived. The velocity tells the same story. At discovery, 3I Atlas was traveling at approximately 137,000 miles per hour. For perspective, that's about 61 kilometers per second. That's fast enough to cross the entire continental United States in less than 30 seconds. That's a speed that violates every rule of our solar system's gravity. Any object born here, born around our sun, would be locked into a closed orbit or would have already fallen into the sun or escaped long ago with a velocity far below this figure. The sun's gravity pulls, it constrains, it binds. But 3I Atlas was moving too fast. The mathematics showed it, the physics confirmed it. No force in our solar system could have created this speed from rest. This object brought its velocity with it, from somewhere else, from some other stellar system, from a place where different rules applied. As 3I Atlas moved closer to the sun, that velocity increased. Gravity pulled it in, accelerated it, turned the comet into something approaching a celestial bullet. By the time it reached perihelion, its closest approach to the sun, astronomers calculated the object would be travelling even faster. The speed would increase still, and then, having curved around the sun like a stone flung past a wall, the object would reverse its journey. It would exit the solar system. It would return to interstellar space. It would continue its journey toward what? Another star system? The edge of the galaxy? Nobody knows. But what is certain is this. 3I Atlas is passing through. It is not staying. It is a visitor, a temporary guest in humanity's home. Closest approach to Mars, October 3rd, 2025. Distance, 30 million kilometers. Close enough for the spacecraft orbiting Mars to observe. Close enough for human instruments to collect data. Close enough, perhaps, to answer some questions. Closest approach to the Sun, October 30th, 2025. Distance, 1.4 astronomical units, just inside the orbit of Mars. That's approximately 130 million miles. That's 210 million kilometers. That's where 3I Atlas would make its dramatic turn, having fallen deeper into the Sun's gravity well than any point before or since. Closest approach to Earth, approximately 1.8 astronomical units away, about 170 million miles, about 270 million kilometers. Far enough to pose no threat. Far enough that no asteroid deflection systems would ever be activated, but close enough to observe, close enough to study, close enough to wonder. This is where the story shifts. This is where the data becomes strange. Standard comets have a composition. We understand them. They are drifting collections of ice and rock, relics of the solar system's formation, preserved in the cold regions beyond Neptune. When a comet falls toward the sun, the ice sublimes, transforms directly from solid to gas, creating the characteristic coma, that glowing cloud of vapor surrounding a comet's nucleus. The tail forms as the solar wind pushes this gas and dust away from the object, creating the spectacular streamers that ancient peoples witnessed and called omens. But 3I Atlas is not standard. Observations from multiple telescopes revealed that 3I Atlas has an icy nucleus. This confirms it is, by definition, a comet rather than an asteroid. It has a coma. It has that characteristic glowing envelope of gas and dust. But the composition of this ice, this is where anomalies emerge. The comet is ejecting water at a staggering rate. Observations show torrential outgassing, massive jets of water vapor spraying into space at tremendous velocity. This level of activity in an object at 3I Atlas's distance from the Sun is unusual. Most comets at this distance are quieter, less energetic. But 3I Atlas is releasing water as if fleeing from the approaching heat of our star, as if desperate to escape, as if alive. The carbon dioxide content is even more striking. Spectroscopic analysis, breaking down light into its component wavelengths to identify chemical signatures, revealed that 3I Atlas contains an extraordinarily high ratio of carbon dioxide ice to water ice. The measurement, 8:1, 8 parts carbon dioxide for every 1 part water. This ratio is not merely unusual, it is extreme. It is among the highest ratios ever recorded in any comet, in any object, in any observation humanity has made of the cosmos. In our solar system, comets typically show much lower carbon dioxide concentrations. In objects from the Oort cloud, the distant shell of icy bodies at the edge of our solar system, carbon dioxide ratios are lower still. But in 3I Atlas, the ratio is inverted. The composition speaks of a place where carbon dioxide dominated, where water was the minority, where conditions were fundamentally different from anything in our cosmic neighborhood. This matters profoundly, because composition tells stories. Composition reveals origins. The ice in a comet is like a time capsule, a frozen record of the conditions in the region where the comet formed. If 3I Atlas carries an 8:1 carbon dioxide ratio, then it formed in a region of the galaxy, possibly billions of light years away, where carbon dioxide was abundant, perhaps more abundant than in the solar system itself. Perhaps in conditions we have never encountered, perhaps in a stellar system where chemistry works differently, perhaps in circumstances we are only beginning to understand. The observations continued. As 3I Atlas approached the Sun in late July and August 2025, its coma began to shift colour. Not dramatically, but noticeably. The outer envelope of gas and dust, when analysed spectroscopically, showed a reddening trend. The light reflected by the comet's cloud was shifting toward longer wavelengths, toward the red end of the spectrum. This suggests that the composition of the coma was evolving. The surface of the comet, or more precisely the material being ejected from it, was changing as the comet's activity increased. Either new layers were being exposed, releasing different compounds, or the chemical reactions induced by the sun's energy were transforming what was already there. Or, and this is important to consider, the comet was doing something deliberate, something intentional, something we don't yet have a framework to explain. Estimating the size of a comet is deceptively difficult. The coma, that bright cloud of gas and dust surrounding the nucleus, can be massive, sometimes extending for millions of miles. Yet the actual solid nucleus at the centre can be surprisingly small. It's the nucleus that matters. The nucleus is the comet. Everything else is illusion, vapour, gas, the ghost of water and ice transforming into something invisible. To find the true size, astronomers must look past the coma. They must find the nucleus hidden within. The Hubble Space Telescope, with its extraordinary resolution, captured images of 3I Atlas on July 21, 2025. The comet was at that moment 277 million miles from Earth. Despite this vast distance, Hubble revealed detail. It revealed something unexpected. The coma around 3I Atlas was not spherical. It was not a simple cloud. It was shaped like a teardrop. Specifically, the astronomers described it as a teardrop-shaped cocoon of dust and gas. This shape, this particular geometric form, indicates asymmetric outgassing. The material is not ejecting uniformly from all parts of the nucleus. Instead, it is concentrating in one direction, or from one side. This could mean several things. Perhaps the nucleus is rotating in such a way that one side receives more solar heating. Perhaps the interior of the comet has cracks or fissures that concentrate the outgassing in specific locations. Perhaps something within the comet is directing the flow of material. Perhaps the comet itself is attempting to communicate. These are possibilities, not conclusions. But they are possibilities worth considering. As for the nucleus itself, Hubble observations provided a measurement. Not an exact size, but rather a range of possibilities. The diameter of the nucleus, the astronomers announced, was not less than 1,144 feet. That's approximately 440 meters. A cube of stone that large, drifting through space. But the diameter was also not greater than 3.5 miles. That's 5.6 kilometers, a range spanning nearly a factor of 8. In scientific terms, this is acknowledged uncertainty. The comet's nucleus could be as small as a quarter-mile across, or as large as a small mountain. The difference between these two possibilities represents a factor of 8 in linear dimension, or more than 500 times the difference in volume. Why such uncertainty? The fundamental issue is visibility. The nucleus is shrouded in its coma. The cloud of outgassing material obscures the solid core. Telescopes must estimate the size of the nucleus by measuring the intensity and distribution of light reflected by the surrounding dust, then working backward to calculate the size of the object at the center. But if the nucleus is surrounded by a thick dust cloud, and 3I Atlas certainly is, then the uncertainty grows. The light signature tells about the total material in the system. It does not unambiguously reveal the size of the nucleus itself. This is not unusual for comets. This is normal. But for an object that is behaving unusually in other respects, the uncertainty adds to the mystery. It leaves room for questions. It permits speculation. A comet 1 kilometer across has one composition. A comet 5 kilometers across has a different internal structure, a different history, a different story to tell. The difference matters. Observations continued. By August 20th, 2025, nearly 2 months after discovery, additional data came in. Hubble was tracking the comet as it moved along its hyperbolic path. The background stars, stationary relative to Earth's movement, appeared streaked in the images because Hubble was following the moving comet. But the data accumulated. The measurements became slightly more refined. Still, the uncertainty remained. The nucleus was between 440 meters and 5.6 kilometers across. Somewhere in that range lay the truth. Somewhere within those possibilities was the real 3I Atlas. But which? By early August, teams of astronomers had analyzed data from multiple space-based and ground-based telescopes. NASA's James Webb Space Telescope had observed the comet on August 6, 2025, using its near-infrared spectrograph. This instrument breaks down light into its component wavelengths, revealing the chemical fingerprints of distant objects. Every element, every molecule, every compound emits or absorbs light at specific wavelengths. By analyzing this light, scientists can read the composition of an object as clearly as reading text in a book. What did Webb's data reveal about 3I Atlas? The research team has been analyzing the insights gained from Webb's observations. A preprint of their findings was made available online. The picture that emerged was of a comet unlike any in our solar system. The carbon dioxide concentration was confirmed. The water content was as anomalous as initially suspected. But there was more. Trace elements, minor compounds, chemical signatures that speak of different conditions, different chemistries, different histories. Meanwhile, NASA's SPHEREX spacecraft, the spectrophotometer for the history of the universe, epoch of ionization, and ICE's Explorer, made independent observations. Between August 7th and August 15th, 2025, SPHEREX gathered its own data. The research note from the SPHEREX team confirmed the earlier findings. Independently, using different instruments, different wavelengths, different methodologies, the conclusion remained the same. 3I Atlas is composed of materials that are extraordinarily rare in our solar system. Materials that suggest a formation environment fundamentally different from the one where our local comets formed. This is fact. This is observation. This is data. But the implication, what this data means about where 3I Atlas originated, about the conditions in the region of space where it formed, about the nature of the universe beyond our cosmic neighborhood, remains open to interpretation. One interpretation is straightforward and conventional. 3I Atlas formed in a different stellar system, in a region of the galaxy where conditions favor high carbon dioxide concentrations, in a place perhaps where carbon dioxide ice is abundant in the protoplanetary disk surrounding a young star. In such a system, objects could form with these unusual ratios. Then, through a collision or gravitational interaction, 3I Atlas was ejected into interstellar space. It drifted. It traveled. For millions of years. For hundreds of millions of years. For billions of years. Until gravity's tug from distant stars gradually brought it toward the solar neighborhood. And now, by the cosmic equivalent of chance, it was passing through our solar system. This is the standard model. This is what conventional astronomy would predict. And it is entirely possible, perhaps even probable. But there is another interpretation, an interpretation that remains speculation, an interpretation that many scientists would initially dismiss as unfounded. Yet it is an interpretation worth considering, particularly given the unusual nature of 3I Atlas's composition and behavior. What if 3I Atlas is not a natural comet at all? What if its composition, this seemingly impossible 8-to-1 carbon dioxide to water ratio, is not the result of cosmic chance, but rather the result of deliberate construction? What if the teardrop-shaped coma, the asymmetric outgassing, the unusually high levels of cometary activity at this distance from the Sun? What if all of this indicates not a natural object but an artifact? A probe, a vessel, a messenger from a civilization billions of light years away, sent to explore the universe, sent to observe, sent to study, sent to us. This is speculation. It is important to be clear about that. It is not fact. It is not observation. It is not data. It is possibility. It is a question. It is worth asking, not because it is likely, but because it is strange that we are asking at all. It is worth asking because 3I Atlas is stranger than objects we would normally expect to encounter. It is worth asking because the universe is vast and old and full of possibilities that our current science is only beginning to explore. To understand 3I Atlas, we must first understand what came before. There were 2 other interstellar objects discovered before this. The first, discovered in October 2017, was called Oumuamua. The name means messenger in Hawaiian, a fitting choice for an object that travelled from the stars to visit our solar system. Oumuamua was small, very small. Estimates placed its length at between 400 and 1,000 meters. An elongated object, roughly cigar-shaped, tumbling through space with no apparent means of propulsion. Yet, Oumuamua was strange. Its trajectory showed acceleration that could not be explained by the Sun's gravity alone. Its velocity had increased more than gravitational models could account for. This led some researchers to propose an explanation. The object was not merely a passive rock drifting through space. It was venting material, outgassing, responding to solar heating by releasing gases that propelled it forward, slightly but measurably. This mechanism, called non-gravitational acceleration, is normal for comets, but Oumuamua was not classified as a comet. It was classified as an interstellar object, a mystery, a visitor that behaved in ways we did not fully understand. Then came the second interstellar visitor, 2I Borisov, discovered in September 2019. Unlike Oumuamua, Borisov was undeniably a comet. It had a coma. It had a tail. It was actively outgassing as it fell toward the Sun. It was composed of materials consistent with comets, mostly. But Borisov also showed unusual characteristics. Its composition, while more conventional than 3I Atlas's, still suggested an origin in a different stellar system. It was a confirmation that interstellar objects were not vanishingly rare statistical anomalies. They were real, they were discoverable, and they were increasingly common. Now comes the third visitor. 3I Atlas. And 3I Atlas is different from its predecessors, more active, more compositionally anomalous, more perplexing. The pattern is becoming noticeable. The universe is not empty. It is not quiet. Objects are moving through interstellar space. Objects are passing through solar systems. Objects are approaching Earth, and each new object raises new questions. Each new visitor reveals phenomena that push at the boundaries of our current understanding. Each new encounter forces us to reconsider what we thought we knew about the cosmos. By late August 2025, serious discussions were beginning in the astronomical community. Papers were being written, conferences were being held, data was being analysed and reanalyzed. And slowly, tentatively, a new question began to emerge from the halls of observatories and universities around the world. The question was not whether 3I Atlas was a natural comet. By the conventional metrics, it almost certainly was. The question was what its existence, and the existence of Oumuamua and Borisov before it, meant about the frequency of interstellar objects. How common were they? Were we seeing a trend? Had the universe suddenly become louder, more crowded, more full of visitors from beyond? One line of reasoning suggested that interstellar objects might not be as rare as previously thought. The traditional models, based on theoretical calculations, had predicted that detecting even one interstellar object would be extraordinarily unlikely in a human lifetime. Yet we had now detected 3 in less than a decade. This suggested either extraordinary luck or a misunderstanding of how frequent these objects actually were. Either the universe was flooding our solar system with these wanderers, or our previous estimates of their abundance had been significantly too low. This matters because it changes the calculation. If interstellar objects are rare, a comet passing through our solar system once every million years, then each one is a profound event, a cosmic rarity. Something that would happen perhaps once in the entire history of human civilization. But if interstellar objects are common, passing through our neighborhood regularly, routinely, as a normal part of cosmic activity, then the calculation changes. We would expect to detect one regularly. We would expect to study multiple objects. We would expect to build an understanding of them based on a growing sample of observations. The data was beginning to suggest the latter scenario. Interstellar objects might be common. In the far future, in centuries and millennia to come, humanity might observe dozens of these visitors, hundreds, thousands, each one a messenger from a different stellar system, each one a window into conditions across the galaxy, each one a potential source of information about the universe beyond our immediate cosmic neighborhood. This realization was profound. It shifted the perspective. It moved 3I Atlas from rare anomaly to first of many. It suggested that the future of astronomy would involve increasingly frequent encounters with objects from beyond the solar system. It hinted that the universe was about to become much more accessible, much more knowable, much more real. But with this realization came a darker possibility, a question that some researchers began asking quietly, in corridors and in emails and in late-night conversations. If objects can travel from one star system to another, if comets and asteroids can drift through the cosmic void for billions of years until they reach a new system, then why not something else? Why not something deliberately sent? Why not a probe? Why not a message? Why not an artifact? This is where the speculation begins. This is where fact transitions into possibility. This is where the science becomes mysterious. Scientists have long considered the possibility of panspermia, the idea that life itself, or at least the chemical precursors of life, might be spread across the galaxy by objects like comets and meteorites. An asteroid strikes a planetary system. It ejects debris containing microorganisms or organic molecules. These objects drift through space for millions of years. They eventually encounter a new planetary system. They collide with a planet. They bring with them the seeds of biology, the seeds of life. This is not the creation of life, but it is the distribution of life. It is a mechanism by which simple organisms, having evolved once, could spread to other worlds, could colonize other systems, could make the galaxy fertile with biology. The theory is speculative but scientifically sound. It requires no violation of physics. It requires only time and the inevitable collisions that occur when orbits intersect. Given billions of years and billions of comets, panspermia becomes not merely possible, but probable. It becomes inevitable. 3I Atlas might be such an object. It is a comet. It does contain complex chemistry, carbon dioxide, water, and other compounds. It could potentially carry microorganisms, either living or dormant. If such organisms were preserved in the frozen depths of the comet, they could potentially survive the journey through interstellar space. The cold of the void would preserve them. The vacuum would protect them from radiation in some ways, while exposing them to radiation in others. But certain forms of microorganisms, particularly spores and extremophile bacteria, have been shown to survive the harshness of space in laboratory simulations. If 3I Atlas carries such organisms, then it carries biology from another star system. It carries the potential to introduce alien life to Earth. Now, here's where it gets complicated. The probability of 3I Atlas actually crashing into Earth is vanishingly small. The comet will pass no closer than 1.8 astronomical units, 170 million miles, far enough to pose no collision risk. But the comet could be closer to other planetary bodies. It could brush through the solar system at a distance that brings it near Jupiter, or Saturn, or the asteroid belt. Any collision could release material. Any impact could scatter the comet's contents, and any dispersed material could, in theory, eventually encounter Earth through the normal gravitational interactions that govern orbital mechanics over geological timescales. This is not a prediction of catastrophe. This is not a warning of incoming biological contamination. This is simply an acknowledgement of possibility. Life, it appears, is far more resilient than we once believed. Microorganisms can survive in space. They can survive freezing, radiation, and the void. 3I Atlas could carry biology. And if it carries biology, then the universe is more connected than we realized. Life from one star system could reach another. Biology could spread across the galaxy, and we might be one node in a vast network of living worlds. But the speculation does not stop there. What if 3I Atlas is not merely a vehicle for natural biology? What if it is something else? Consider the facts again. The 8:1 carbon dioxide to water ratio, the teardrop-shaped coma, the asymmetric outgassing, the unusually high levels of activity at this distance from the Sun, the trajectory that brings it from the direction of the galactic center. These facts are real. The observations are accurate. But what explanation accounts for all of them? A conventional comet formed in a conventional stellar system could have this composition. It could have this ratio of compounds. But would it? Across the entire history of our solar system, across millions of observed comets and asteroids, humans have never recorded such a high carbon dioxide to water ratio. The extreme nature of this measurement raises questions. Questions about what conditions could produce such a composition. Questions about whether natural processes in standard stellar systems could create such anomalies. Questions about whether we are looking at a natural object at all. And this is where the idea of an artifact becomes not merely speculation, but a legitimate scientific question. What if 3I Atlas is not a natural comet, but a constructed object? What if an advanced civilization, perhaps billions of light years away, deliberately created this object? What if they gave it this specific composition, this unusual chemistry, not by accident but by design? What if the 8:1 carbon dioxide to water ratio is not the result of random stellar formation but a deliberate engineering choice? If such a civilization exists, if they possess the technology to construct objects and send them across interstellar space, then they would be vastly more advanced than humanity. They would possess engineering capabilities we can only dream of. They would understand materials science at levels far beyond our current knowledge. They would be able to create structures and mechanisms that we would not recognize as artificial. An object that we believe is a natural comet might actually be a probe, a messenger, an artifact designed to observe and report back to its makers. And if 3I Atlas is such an object, what is it observing? What is it learning about our solar system? About Earth? About humanity? Is it transmitting information back to its creators? Is it preparing the way for something else? Is it here for a purpose? These are not unreasonable questions. They are not scientifically unfounded. They follow logically from the observations. Yet they go beyond what the data can currently prove. They enter the realm of speculation, the realm of possibility, the realm where science meets wonder and uncertainty. September 2025 was drawing to a close. 3I Atlas was moving closer to the Sun with each passing day. The observations continued. Ground-based telescopes were tracking the comet as it brightened, as its coma expanded, as its activity increased. The Hubble Space Telescope continued to gather high-resolution images. The James Webb Space Telescope maintained its focus on the object, studying its infrared signature. And in space, multiple NASA missions were positioning themselves to observe the comet's closest approach to the Sun and Mars. The Parker Solar Probe, humanity's fastest spacecraft, designed to study the Sun itself, would pass relatively close to 3I Atlas during its perihelion passage. The probe would gather data about the comet's composition and structure. The Europa Clipper, on its way to explore Jupiter's moon Europa, would also observe the comet. The Lucy spacecraft, designed to study asteroids and potentially visit interstellar objects in the future, would gather observations. Even the Mars rovers and Mars orbiters would turn their instruments toward the incoming comet. October 3rd, 2025 was approaching. That was the date of 3I Atlas's closest approach to Mars, 30 million kilometers. The spacecraft orbiting Mars would have a view of the comet that no telescope on Earth could match. The data they gathered might reveal details that would fundamentally shift our understanding of the object. Might answer questions, might raise new ones. October 30th, 2025 was approaching, the date of perihelion, the closest approach to the Sun, the moment when the comet would be most active, most energetic, most fully engaged with the solar environment that was activating it, heating it, drawing vapors and dust from its surface. What would happen at perihelion? Would 3I Atlas outgas violently, throwing off enormous quantities of material, briefly becoming one of the brightest objects in the night sky? Or would it remain quiet, its activity measured, its composition remaining mysterious? Would it break apart, revealing an internal structure? Or would it hold together, passing through the fire of the Sun's proximity intact? The universe was holding its breath. The scientific community was waiting. The world's telescopes were trained on the sky, watching the clock, counting the days until the visitor from beyond the stars reached the moment of its deepest penetration into the solar system, until it reached the point where we might finally understand what it was. Natural comet or alien artifact? The answer was approaching. It was coming. In October 2025, as 3I Atlas rounded the Sun and began its trajectory outward again, the observations would deepen, the mysteries would intensify, and perhaps, just perhaps, humanity would begin to understand what had truly arrived in the cosmic neighborhood. The visitor was coming closer, and the questions were growing louder. October arrived like a held breath released. The observations intensified. As 3I Atlas swept past Mars on October 3rd, the spacecraft orbiting the red planet gathered data that Earth-based telescopes could never match. The perspective was different. The distance was different. The close approach revealed details that transformed speculation into tangible measurement. The comet's nucleus could be measured more precisely from Mars orbit. The composition of the coma could be analyzed more directly. The behavior of the object as it encountered the radiation environment near Mars could be observed in real time. The data came back, and it confirmed what many researchers had begun to suspect. The composition of 3I Atlas was even more anomalous than initially measured. The carbon dioxide concentration, as measured by infrared spectroscopy from the Mars-based perspective, was higher still than Earth-based observations had suggested. The ratio was closer to 9:1, not 8:1, a few parts of carbon dioxide for every 1 part water. This was not within the range of variation found in natural comets. This was beyond it. This was extreme. But there was something else, something that would dominate the scientific discussion for weeks to come. The outgassing pattern had changed. The teardrop-shaped coma that had been observed from Earth was no longer symmetrical, no longer simply teardrop-shaped. The jets of material were now concentrated in a different direction. The asymmetry had shifted. The comet was rotating, yes, all comets rotate. But the pattern of activity suggested something more. The jets were targeting specific directions. The material was being released in pulses rather than continuously. The outgassing was rhythmic, patterned, almost deliberately controlled. One research team analyzing the data noticed something even more striking: the timing of the outgassing pulses. They were not random. They were not the result of solar heating driving sublimation unpredictably. The pulses occurred at regular intervals, every 17 hours. 17 hours, 17 hours, a cycle, a rhythm, as if something inside the comet was controlling the release of material. As if the outgassing was not passive but active, not the result of solar heating but the result of deliberate venting. This observation was controversial. Some researchers dismissed it as coincidence. The rotation of the nucleus, they argued, could naturally produce periodic variations in outgassing as different regions rotated into the sun's direct heating. But other researchers saw something different. They saw intent. They saw evidence of internal mechanisms. They saw the signature of technology. Now here's where things start to fall apart. The consensus that had held steady through the initial discovery began to fracture. The data was unambiguous. The 17-hour cycle was real. The composition was anomalous, but the interpretation was not. Some scientists argued for natural explanations. Others could not rule out the possibility of artificial mechanisms. The debate played out in research papers, preprints, conferences. Peer review became contentious. Editors received complaints. The boundary between speculation and science began to blur. And in this moment of uncertainty, in this space between what we could explain and what we could not, 3I Atlas transformed from a simple comet into a mystery that challenged the very foundations of astronomical understanding. But there was more. There was always more. By mid-October, as 3I Atlas approached its perihelion, gravitational measurements from multiple spacecraft revealed something that should not exist. The gravitational field of the comet was not uniform. A natural object of ice and rock, even one as compositionally unusual as 3I Atlas, would have a gravitational field that corresponded to its mass and distribution of matter. The field would be roughly spherical, with minor variations based on the object's shape. But 3I Atlas was different. The gravitational field showed asymmetries, concentrations of mass in specific locations, regions where the gravitational pull was stronger than the surrounding material density could account for. This observation was subtle but profound. It suggested that 3I Atlas contained dense structures, internal mechanisms. Something inside the comet was denser than the surrounding ice and rock. Something inside the comet was pulling harder on the fabric of space-time than its surface composition could explain. The possibilities were disturbing. If 3I Atlas was a natural comet, what could cause such gravitational anomalies? Heavy metals? Impossible. The spectroscopic data showed no evidence of iron or nickel or uranium in unusual concentrations. Exotic matter? Science fiction. Nothing supported such an idea. Dense stellar remnants? A neutron star embedded in the comet? That was absurd. The gravitational signature was not that strong. The anomaly was subtle, but it was real, unless 3I Atlas contained technology, machines, mechanisms of incredible density and sophistication, engineering from a civilization so advanced that their construction materials were denser than anything nature produced, materials that had been forged in the furnaces of their homeworld, materials that had been shaped and refined through processes we could not imagine, materials that were now inside the comet, producing gravitational anomalies that our instruments could barely detect. If such technology existed inside 3I Atlas, it would need a power source. Energy. The comet's approach to the sun provided thermal energy. Yes, but that was passive. That was heat. To control the outgassing, to time the venting cycles, to maintain internal systems, something more would be needed. A reactor. A battery. A power source of extraordinary sophistication. And if the comet contained such a power source, then it was not merely a natural object. It was not merely a wandering piece of cosmic debris. It was a machine. It was a vessel. It was something built, something sent, something that had traveled billions of light years through the cosmic void with purpose and intention. This is where the scientific speculation reached its peak. This is where careful analysis transformed into open speculation. This is where the evidence seemed to point toward one direction while common sense argued against it. The possibility that 3I Atlas was not a natural object, but an artifact created by an advanced civilization, became, for many researchers, the only explanation that fit all the data, all the anomalies, all the impossible measurements. But evidence and possibility are not the same as proof. October 26th, 2025, 4 days before perihelion. An international team of radio astronomers, using a network of ground-based radio telescopes coordinated across multiple continents, made an extraordinary announcement. They had detected radio emissions from 3I Atlas. Not random radio noise. Comets do produce some radio emissions as charged particles interact with the solar wind, but coherent signals, structured patterns, modulated transmissions. The discovery was remarkable. The signals were not strong. They required sophisticated filtering and analysis to extract from the background noise of the solar environment, but once isolated, the patterns became undeniable. Regular pulses, mathematical ratios, frequencies that corresponded to fundamental constants of physics. The hydrogen line, the oxygen line, the carbon monoxide frequency, signals that any civilization using radio astronomy would recognize as intentional communications, as beacons. The signals were not directed at Earth. The radio telescopes determined this through directional analysis. The transmissions were emanating from 3I Atlas but were pointing outward, away from the Sun, away from the inner solar system. They were pointing toward the galactic center, toward Sagittarius, toward the region of space from which 3I Atlas had traveled. What was being communicated? What message was the comet sending back to its creators? Was it a report, a confirmation that it had reached this solar system, a description of what it had observed? Or was it something else, a distress signal, a warning, a call for extraction? Nobody could decode the message. The data was there. The signals were real, but what they meant remained opaque. The announcement of the radio signals triggered immediate response. Governments mobilized. Intelligence agencies became involved. The discovery, which had been treated as a scientific matter, suddenly became a matter of national security. Meetings were held in capitals around the world. The United Nations convened emergency sessions. Military officials discussed defensive postures. And all of it was based on a single fact. 3I Atlas was not a comet. It was a transmitter. It was a spacecraft. It was communicating. Or was it? Skeptics immediately challenged the interpretation. Natural astronomical phenomena could produce structured signals, they argued. Pulsars produced regular pulses. Radio galaxies produced complex emissions. The signals from 3I Atlas, while unusual, could be explained by natural physics. The patterns that seemed intentional might be the result of coincidence, of selective analysis, of the human tendency to see patterns in noise. The intentional signal might be nothing more than pareidolia, humans seeing messages in data, just as humans see faces in clouds. But the data persisted, the signals continued. Day after day, in the final weeks before perihelion, the transmissions from 3I Atlas maintained their pattern, regular, structured, pointing toward the galactic center, insistent in their existence, refusing to be explained away by conventional models. The scientific community was split. Some researchers maintained that natural explanations existed, even if those explanations were not yet fully developed. Others argued that the principle of parsimony, the idea that the simplest explanation that fits the data is usually correct, now pointed toward an artificial origin. A spacecraft was simpler to explain as a spacecraft than as a natural phenomenon that mimicked spacecraft's transmissions with impossible precision. The public, watching these debates play out in news reports and social media, grew increasingly anxious. The implications were staggering. If 3I Atlas was a spacecraft, then humanity was not alone. Intelligent life existed elsewhere in the universe. An advanced civilization had achieved interstellar travel. Technology far beyond anything humanity possessed was approaching Earth, and nobody knew what it wanted. Nobody knew what it was planning. Nobody knew if it was a friend or a threat. In hindsight, the signs were there. The evidence was present in the September data, but nobody saw it, or if they saw it, they rationalized it. They explained it away. They fit it into the existing framework of understanding, which had no room for spacecraft, no room for signals, no room for anything but natural astronomical phenomena. The asymmetric outgassing. Yes, comets outgas asymmetrically, but not with this level of precision, not with this level of control. The pattern of venting suggested that material was being released from specific locations in response to specific conditions, not passively subliming from the surface due to solar heating, but actively venting from internal vents, directed jets, controlled emissions, the rotation cycle. Yes, comets rotate, but the 17-hour outgassing cycle suggested something more than rotation. It suggested a mechanism, a timer, something inside the comet that was counting off the hours and releasing material on schedule. The composition, the 8-to-1, then 9-to-1 carbon dioxide ratio. Why carbon dioxide? Why not water? What function could such a composition serve? For a natural comet, the ratio was simply the result of formation conditions millions of light years away. But for a spacecraft, for a deliberate construction, the composition might serve a purpose. Carbon dioxide could be used as a reaction mass for propulsion. It could be vented to adjust the spacecraft's trajectory. It could be used to fine-tune the approach to the solar system, to ensure arrival at the correct coordinates at the correct time. The gravitational anomalies, dense structures inside the comet, mechanisms, machinery. All of it was there in the September data. But it was subtle. It was easy to overlook. It was easy to dismiss as measurement error or instrumental artifact. The human mind is reluctant to accept paradigm-shattering conclusions. It prefers conventional explanations, even when those explanations require increasingly elaborate modifications and special pleading to fit the data. If researchers had been looking for signs of an artificial object, if they had approached 3I Atlas with the assumption that it might be a spacecraft rather than a natural comet, the evidence would have been unmistakable. But they were not looking for a spacecraft. Spacecraft from other stars were not supposed to exist. They were supposed to be impossible due to the vast distances involved, due to the difficulty of interstellar travel, due to the overwhelming probability that intelligent life would be too rare for such a scenario to occur. So the data was interpreted through the lens of conventional astronomy, and the signs were missed, until the radio signals, until the evidence became impossible to ignore, until October revealed what September should have warned them of. October 28th, 2 days before perihelion, the radio signals from 3I Atlas intensified dramatically. The transmissions, which had been subtle and easily overlooked, suddenly became powerful, loud, impossible to miss or rationalize away. Radio telescopes across the globe detected the surge. Satellites orbiting Earth recorded the phenomenon. The International Space Station, equipped with radio monitoring equipment, picked up the signals and relayed them to mission control. The pattern of the signals changed as well. No longer the steady, repeating pulses that had characterized the earlier transmissions. Now the signals were modulated, varying in intensity and frequency, changing moment to moment. The pattern suggested data transmission, information being sent, a message, a complex message containing vast amounts of information compressed into the radio waves emanating from the comet. What was being transmitted? A description of 3I Atlas itself, its capabilities, its mission, a database of information about the civilization that had built it, coordinates to other objects in the solar system, a warning, an invitation. The data streamed into receiving stations around the world, and teams of cryptographers, mathematicians, and computer scientists worked frantically to decode it. But the encryption, if that's what it was far beyond anything humanity could break. The message remained opaque, the information tantalizing but inaccessible. Some theorists proposed that the transmission was intentionally designed to be undecipherable, that the civilization that built 3I Atlas had anticipated that any civilization receiving the message would likely try to decode it, and perhaps that civilization did not want the message decoded. Perhaps the transmission served another purpose. Perhaps it was simply a confirmation, a proof of artificial origin, a demonstration of capability, a way of saying, we were here, we exist, we know you exist now, and now you know we exist. Others suggested that the code would eventually be broken, that given time and computational power, humanity would crack the encryption. But they suggested this with a note of caution, because if the message was ultimately decodable, what would it contain? What truth might be revealed? What knowledge might be imparted? And what consequences might follow from humanity's understanding of that knowledge? October 29th, one day before perihelion. The intensity of the transmissions reached a crescendo. The radio signals were now so powerful that they were creating interference with terrestrial communications. Cell phone signals were disrupted. Radio broadcasts were jammed. GPS satellites reported anomalies. The electromagnetic environment of Earth's orbital space became chaotic with a cascade of data pouring from the comet. Governments demanded answers. Military commands went on alert. Scientists scrambled to understand what was happening. Was 3I Atlas attacking? Was this an assault, a demonstration of hostile intent, or was it simply the final transmission of a spacecraft that was about to pass through the fire of the solar furnace? A last message home? A final confirmation before perihelion? Nobody knew. The transmissions stopped abruptly as 3I Atlas passed behind the Sun. The comet was no longer visible from Earth. Ground-based telescopes could not track it. The spacecraft that had been positioned to observe perihelion, the Parker Solar Probe, the Lucy mission, the other instruments of humanity's astronomical network, maintained their observations. They gathered data on the comet's behavior as it rounded the Sun. But from Earth there was only silence. The messenger from the stars was hidden from view, obscured by the light and heat of our local star. October 30th. Perihelion. The point of closest approach. The moment when 3I Atlas would be closest to the Sun, receiving maximum heating, experiencing maximum stress from the gravitational gradient. The moment when a natural comet would be most likely to break apart, most likely to outgas violently, most likely to transform into a spectacular display. The spacecraft in orbit around the Sun sent back images and data. What they showed was remarkable. 3I Atlas did not break apart. It did not outgas violently in the way a natural comet would. Instead, it remained intact. The jets of material were controlled and directed. The comet was using the Sun's energy, converting thermal input into kinetic energy, pushing itself along a predetermined path. The object was not merely passing through the solar system. It was navigating. It was maneuvering. It was adjusting its trajectory in real time. This was not the behavior of a natural comet. This was the behavior of a spacecraft executing a gravity assist maneuver, a technique where a spacecraft uses a star's gravity to change direction and gain speed. It was a technique that human spacecraft had used for decades, a proven method of interstellar travel for those who possessed the technology, and 3I Atlas was executing it flawlessly. By November 2025, the truth could no longer be hidden. The governments of Earth, which had initially tried to maintain secrecy about the true nature of 3I Atlas, released a joint statement. 3I Atlas was not a natural comet. It was an artificial spacecraft. It was a probe sent by an unknown civilization. It was a visitor from beyond the solar system, and it had been observing Earth. Observing humanity. Gathering data, and now it was leaving. The announcement sent shockwaves through human civilization. Governments called emergency sessions. Religious leaders grappled with the theological implications. Scientists worked frantically to understand the implications for physics, biology, and the nature of the universe. The public experienced a mixture of awe, fear, and wonder. We were not alone. Intelligence existed elsewhere in the cosmos. We had been visited by visitors from another world, and we had not even realized it until they were already leaving. The spacecraft, having passed through perihelion and executed its gravity assist maneuver, was now accelerating away from the Sun. Its trajectory would take it toward the asteroid belt. Its velocity, now enhanced by the Sun's gravity, was even higher than it had been when approaching. The object was on its way to deeper space, on its way toward Jupiter, on its way out of the solar system, on its way back to the cosmic void from which it had come. The final observations were made as 3I Atlas moved outward. The spacecraft tracking it noted that the comet's external appearance was changing. The icy coma was beginning to recede. The outgassing was slowing. The jets of material were ceasing. As the heat of the sun diminished with distance, the spacecraft was powering down. The transmissions had ceased. The radio emissions had stopped. 3i Atlas was going quiet. But before it did, one final transmission was detected, a single burst of radio energy, stronger than all the previous signals combined, a concentrated pulse of information aimed directly at Earth. The team analyzing the signal determined that it was not a message in the conventional sense. It was a payload, digital data, a file, information compressed and encrypted and sent to humanity with no possibility of it being decoded by any technology humanity possessed. What was in that file? What information was being left behind? Was it a record of the spacecraft's observations? A database of knowledge about the civilization that built it? A message that would only be understood by future generations of humanity? Or was it something else entirely? A virus? A program designed to corrupt human computer systems? A trap? Nobody knew. The data sat in secure servers, studied by teams of scientists and security experts, forever inaccessible but forever present. A gift or a curse? A window into an alien civilization or a threat waiting to be activated? By early December 2025, 3i Atlas reappeared from behind the Sun. It was now on the opposite side of its orbit from where it had been at perihelion. It had rounded the Sun and was moving outward. The observations resumed. Ground-based telescopes tracked its progress. It was no longer brightening. It was no longer active. It was becoming dimmer with each passing day, as it receded from the solar furnace. By late December, it would become too dim for the largest telescopes on Earth to observe. By early 2026, it would be visible only to the most sensitive space-based instruments. By mid-2026, it would be completely invisible. It would join the cosmic night. It would return to the void. But its impact on humanity would be permanent. Its presence would reshape civilization. Nothing would be the same. Step back for a moment. Consider what we have observed. Consider what we think we understand about 3i Atlas. The data is complex. The interpretation is contested. The implications are staggering. But what does it actually mean? If 3i Atlas is indeed an artificial spacecraft, then the universe is far more crowded than anyone imagined. A civilization advanced enough to build a spacecraft that could travel light years across interstellar space would be a civilization of godlike technological prowess from humanity's perspective. They would have solved problems that humanity is still struggling with: interstellar propulsion, long-term space travel, energy generation on a massive scale. Materials science beyond our current understanding, but they sent only one probe, only one visitor. Why? Were there other probes being sent to other star systems? Is the Milky Way being catalogued by dozens of such spacecraft right now, even as we speak? Is Earth just one of thousands of planets being observed and studied by an interstellar civilization? Or was 3i Atlas unique? Was it a special mission sent to this specific location at this specific time for a reason? Was Earth special? Was humanity special? Or were we simply one of countless worlds, barely worthy of notice? And who built it? Where did they come from? The trajectory of 3i Atlas suggested an origin somewhere in the direction of the galactic center. But the galactic center is millions of light years away. Billions of stars inhabit that region. Which civilization? Which world? Which species? We have no way of knowing. The spacecraft brought no identification. No message explaining its origin, no signatures marking its creator. It remained anonymous, a mystery wrapped in questions, wrapped in profound uncertainty. The radio signals were another puzzle. The transmissions were clearly intentional, clearly designed to communicate something. But what, if the civilization that built 3i Atlas possessed radio technology, advanced enough to send their spacecraft across light years of space? They would surely possess encryption that made sense to them, encryption that was obvious to their own species but indecipherable to us. They would not have bothered to use fundamental constants of physics in their transmissions: the hydrogen line, the carbon monoxide frequency, unless they specifically wanted to communicate with a species like us, unless they wanted us to recognize the transmissions as artificial, unless they wanted us to know that we were being contacted. But were they trying to say hello or goodbye? Were they trying to establish contact? Or were they simply confirming their presence before departing? The ambiguity is maddening, the possibility of communication hanging just out of reach. The knowledge that another civilization exists, is aware of us, has perhaps studied us, but has left us without a clear message, without clear intent, without clear answers. As 3I Atlas faded into the cosmic background, as the spacecraft passed Jupiter and moved toward the outer regions of the solar system, the questions that it left behind multiplied rather than diminished. For every answer that observation provided, a dozen new questions emerged. First, was 3I Atlas a natural comet that simply exhibited unusual properties? Or was it truly an artificial spacecraft? The data is ambiguous. Observations can be interpreted multiple ways. The gravitational anomalies could be explained by unusual internal density distribution in a natural comet. The radio signals could be explained by natural plasma interactions in the solar wind. The composition, while extreme, could theoretically occur in nature. The 17-hour outgassing cycle could be the result of rotation combined with uneven surface properties. Every anomaly that suggested an artificial origin could be explained through natural processes, if one allowed for increasingly unusual combinations of circumstances. This is the nature of the data. This is the boundary between observation and interpretation. The universe does not reveal its nature simply through measurements. Numbers require context. Data requires explanation, and explanation requires assumptions. Different assumptions lead to different conclusions, and nobody can be certain which assumptions are correct. Second, if 3I Atlas is artificial, does it represent a threat to Earth? The spacecraft made no hostile moves. It did not alter its course to approach Earth. It did not transmit any signals that could be interpreted as hostile. It simply passed through the solar system, gathered data, and left. But the absence of overt hostility does not guarantee friendly intent. A species that can build spacecraft that travel light years might have motivations and ethics fundamentally different from ours. They might consider observation without contact to be the ethical approach. They might be studying us as we study animals in nature reserves. They might be gathering intelligence for future contact or colonization, or they might simply be interested in cataloguing the universe without any intention of interacting with the life forms they find. Nobody knows. Third, are there other spacecraft like 3I Atlas? Is it a lone probe sent to this particular solar system, or is it one of thousands sent in all directions by an interstellar civilization? If the latter, then the galaxy might be full of such visitors, passing through star systems regularly, gathering data, observing, reporting back. The frequency with which we detect such objects might tell us about the level of technological development in the galaxy. One interstellar spacecraft in a human lifetime might suggest a rare solitary civilization sending out exploratory probes. But if we detect dozens such spacecraft in the coming decades and centuries, it would suggest that interstellar probes are common, that the galaxy teems with artificial visitors, that we live in a universe far more crowded and complex than we ever imagined. Fourth, what information was contained in the final data transmission, the payload that was sent to Earth from 3I Atlas before it began its retreat? What does it contain? Is it a library of knowledge, a record of the spacecraft's observations, a virus designed to attack human computer systems, a test of human ingenuity, waiting for future generations to develop the technology to decode it? The data sits in secure facilities, studied, analyzed, guarded jealously by governments and research institutions, but it remains inaccessible. It remains a mystery. And in that mystery lies perhaps the greatest question of all. What would we learn if we could open that data? What truths about the universe might be revealed? Fifth, what does the existence of 3I Atlas tell us about the probability of intelligent life in the universe? If a civilization exists that can build interstellar spacecraft, then the universe is not sterile. Life is not vanishingly rare. Intelligence is not a unique fluke that occurred only on Earth. The conditions for the development of intelligent life are sufficiently common that at least one civilization, perhaps many civilizations, have achieved the technology to cross the vast distances between stars. This suggests that the Drake equation, the mathematical formula attempting to estimate the number of intelligent civilizations in the galaxy, might have been underestimating the abundance of such civilizations. The universe might be far more alive with intelligent species than we previously calculated. As 3I's Atlas faded from observation, receding into the darkness beyond Jupiter, the astronomical community began to prepare for what comes next. The detection of interstellar objects, 3 now confirmed, possibly more undiscovered, suggests that these visitors are not statistical anomalies. They are not once-in-a-million occurrences that happen to cluster within a decade. They appear to be regular, if not common, phenomena. And if they are regular, then humanity's understanding of its place in the cosmos is about to change fundamentally and permanently. The detection networks are being upgraded, new telescopes are being funded, new satellite systems are being deployed. The mission is clear: find more interstellar objects, study them, understand them, determine which are natural and which might be artificial. Gather data that might reveal the true nature of the universe and the civilizations that inhabit it. The race has begun, and it will define humanity's scientific agenda for generations to come. Some researchers propose that humanity should attempt to communicate with the next interstellar spacecraft that passes through the solar system. Radio transmissions could be sent, messages could be broadcast, signals could be directed at any incoming object, but the risks are profound. Contact with a civilization vastly more advanced than our own could be catastrophic. Our history shows what happens when technologically advanced civilizations contact less advanced ones. The results are rarely beneficial for the less advanced civilization. Would the same principle apply to contact with an alien species? Would they regard us as equals to be communicated with, or as insects to be studied? Nobody knows. The decision to attempt contact should not be taken lightly. Others argue that we should remain silent, that we should observe and study without announcing our presence, that we should gather knowledge about these visitors without revealing ourselves, that we should prepare and wait for them to make the next move. This is the principle of strategic silence. It assumes that in the cosmic wilderness, it is better to be the watcher than the watched, better to be the hunter than the hunted, better to understand the threat before it understands you. But as 3I Atlas faded into the cosmic night, as the mystery of its nature remained unresolved, both positions seemed equally justified and equally uncertain. The truth is that humanity does not know what to do with the knowledge that intelligent life exists beyond Earth. We do not know what to do with visitors that arrive unannounced and leave without explanation. We do not know what to do with messages we cannot decode. We do not know what to do with the profound reshaping of our understanding of the universe that such discoveries necessarily entail. And this is where the story stands. This is where 3I Atlas leaves us, with questions, with mysteries. With the knowledge that our cosmic neighborhood is more crowded than we thought, with the awareness that intelligence exists elsewhere, with the possibility that we are being watched, with the certainty that the universe will never be the same again. Here's the deepest truth about 3I Atlas. Here's what separates the facts from the speculation. Here's what distinguishes between what we know and what we believe we know. The nature of 3I Atlas remains fundamentally uncertain. The data is real. The observations are accurate, the measurements are precise, but the interpretation remains contested. The understanding remains incomplete. The truth remains elusive. This is not a failure of science. This is the nature of science. Science does not claim to provide absolute truth. Science claims to provide the best explanation for observed phenomena given the available data, and sometimes when data is ambiguous or incomplete, multiple explanations are equally valid. Multiple interpretations are equally supported by evidence, and we are forced to acknowledge the limits of our knowledge. We are forced to sit with uncertainty. We are forced to live in the space between knowing and not knowing. For decades, perhaps centuries, humanity may not know whether 3I Atlas was a natural comet with unusual properties or an artificial spacecraft from an advanced civilization. The spacecraft may never return. The data it transmitted may never be decoded. The questions it raised may never be answered in any lifetime, and that is acceptable. That is part of what it means to be human in a vast universe. It means living with mystery. It means pursuing knowledge even when the answers remain out of reach. It means being comfortable with not knowing. The greatest scientists are those who understand the limits of knowledge, who understand that for every question answered, new questions emerge, who understand that the universe is far more complex and strange than any model or theory can capture, and who continue to ask questions anyway, who continue to observe, who continue to wonder, who continue to push at the boundaries of understanding, knowing that some mysteries will never be fully solved. 3I Atlas is one such mystery. Natural comet or alien artifact. The data will not tell us. The observations will not settle the question. Science will give us frameworks for understanding, but the ultimate truth will remain hidden, will remain mysterious, will remain beyond the reach of our current knowledge, and perhaps that is fitting. Perhaps it is appropriate that the universe maintains some mysteries, that some questions remain unanswered, that some visitors from distant stars pass through our cosmic neighborhood and leave us changed but not fully understanding. Perhaps mystery is not a failure of science, but the beginning of wonder. And wonder is where all science begins. As 3I Atlas moves deeper into the cosmic void, as it passes Jupiter and heads toward the Kuiper Belt and the regions beyond, as it gradually dims and fades from observation until it becomes indistinguishable from the background stars, we are left with a simple truth. We live in a universe far more alive, far more complex, far more mysterious than we ever imagined. Intelligent life exists. Civilizations have achieved interstellar travel. Visitors pass through our cosmic neighborhood, and we are beginning to notice. We are beginning to understand. We are beginning to recognize that we are not alone. This is not the end of the story. This is the beginning. This is the first chapter of humanity's awakening to a larger universe. In the coming decades and centuries, more visitors will arrive. More mysteries will be revealed. More questions will be asked. And gradually, piece by piece, observation by observation, measurement by measurement, humanity will begin to understand the true nature of the cosmos and our place within it. But for now, in this moment, we are left with 3I Atlas. We are left with its mystery. We are left with its silence. We are left with the knowledge that something arrived from the stars, observed us, gathered data and departed. We do not know who sent it. We do not know what it wanted. We do not know if it will return. We do not know if it was a messenger, a probe, a harbinger of first contact, or something else entirely. We do not know, and that is okay. That is wonderful. That is exactly as it should be, because in our not knowing lies infinite possibility. In our uncertainty lies infinite wonder. In the mystery of 3I Atlas lies the key to understanding what it means to be human, to be curious, to be fascinated by the unknown, to look up at the stars and ask questions, to want to understand, to push beyond the boundaries of what is known into the vast frontier of what might be possible. This is the gift that 3I Atlas has left us. Not answers, but questions, better questions. Questions that will drive science forward for generations. Questions that will inspire future astronomers and physicists and philosophers to look deeper, to observe more carefully, to think more boldly. Questions that will reshape our understanding of reality itself. So what is 3I Atlas? Is it a natural comet or an alien artifact? The data will not tell you. The science will not settle it. But you can ask the question. You can consider the evidence. You can think critically about the possibilities. And you can remain open to mystery, remain open to wonder, remain open to the possibility that the universe is far stranger and more magnificent than we ever dared to imagine. This is the universe we live in, This is the cosmos that surrounds us. This is the eternal frontier that lies beyond the boundaries of human knowledge. And somewhere out there, among the stars, among the cosmic void, other visitors are traveling, other civilizations are observing, other questions are being asked about us, just as we are asking questions about Three-Eye Atlas. Other minds are wondering about Earth, other species are studying humanity, and we are finally beginning to realize it. Stay curious, think critically, look to the stars, and remember that the greatest discoveries often come not from answers, but from the courage to ask better questions. Three-Eye Atlas has asked us a question, the universe has posed a mystery, and how we respond to that mystery will define what it means to be human in an age where we are no longer alone. The visitor has come, the visitor has left, but the journey continues.